Hi, it's Alan Begg here. Today I'm going to continue on with my presentations on three-dimensional objects. Today is going to be part 3, worked examples. Here's a brief reminder of some examples of 3D objects: cylinder, cone, cube, sphere, pyramid, and prism. First example we're going to look at is a cube. Here's the volume formula for a cube: A cubed, which means A times A times A times A times A cubed. Here's the example we're going to look at. Let's substitute these numbers into this formula. So the volume will be 8 cubed. 8 cubed is 8 times 8 times 8, which is 512. And remember, the units are cubic meters, or meters cubed. Next example we're going to look at is a cuboid, or a rectangular prism. Volume formula is length times width times height. Length times width times height. Here's a worked example. Here's a reminder of the formula. Let's put these numbers into this formula. L for length, 4 centimeters. W for width, 5 centimeters. H for height, 3 centimeters. So 4 by 5 by 3. Simplify it to 20 by 3, and the answer is 60 centimeters cubed. Next example is a triangular prism. Volume formula for a triangular prism is the area of the cross section times the length. In this instance of the triangular prism, the cross section is a triangle. Let's put these figures into this formula. So width, 4 centimeters, height, 3 centimeters, length, 5 centimeters. A half of 4 times 3 times 5. BODMAS applies, so let's do the things in the brackets first. 4 by 3 is 12. A half of 12 times 5. Half of 12 is 6. 6 times 5. 6 times 5 is 30 centimeters cubed. Next example is a trapezoidal prism. The volume formula for a trapezoidal prism is half times B1 plus B2 times H times L. B1 is this length at the top, B2 is this length at the bottom, H for height and L for length. Let's substitute these figures into this formula. What does B1 equal for this example here? B1 is 8 centimeters. B1, 8 centimeters. What's B2? B2 is 14 centimeters. B2, 14 centimeters. What's H? H is 4 centimeters, the height. H is 4 centimeters, the height. What's L? L is 10 centimeters, the length. L is 10 centimeters. B1, 8 centimeters, B2, 14 centimeters, H, 4 centimeters, and L, 10 centimeters. Let's put that into the trapezoidal volume formula. Half times 8 plus 14 times 4 times 10. BODMAS. So let's do the things in brackets first. 1/2 times 22 times 4 times 10. Let's start simplifying. 1/2 of 22 is 11, 4 times 10 is 40. 11 times 40 is 440 centimetres cubed. Next example is a pyramid. Here's the volume formula for a pyramid. 1/3 of the area of the base times the height. This example of a pyramid has got a square base. The area of a square is a squared. So in this example, the area of the base, which is a square, would be 4 squared. Let's put these figures into the formula. 1/3 times 4 squared times 5. 4 squared is 16. 1/3 times 16 times 5. Volume equals 26.67 recurring centimetres cubed. Next example, cylinder or circular prism. Volume formula for a cylinder, pi r squared h. Let's put these values into this formula. There's the radius, 3 millimeters, 3 meters, the height, 2 meters. Pi, 3.14 to 2 decimal places. R, 3, r squared, 3 squared, times h is 2. 3.14 times 9 times 2 equals 56.52 meters cubed. Next example, cone or a circular pyramid. Volume formula for a cone, 1/3 times pi r squared h. In this worked example, r is the radius 5 centimeters, h is the height 9 centimeters. 1/3 times pi to 2 decimal places 3.14 times r squared 5 squared times h 9 equals 235.5 centimeters cubed. Next example, a sphere. The volume formula for a sphere is 4/3 times pi r cubed. In this example, the radius r is 20 centimeters. Let's input that into the formula. 4/3 times pi 3.14 to 2 decimal places times 20 cubed, r cubed. R equals 20. That results in 33,493.3 centimeters cubed. Now, it's vitally important that you consider the impact of how many decimal places of pi that you use. Pi to 2 decimal places would be 3.14, 2 decimal places. Pi to 7 decimal places would be 3.1415927. Let's look at the same example with 2 different decimal places for pi. Here is pi to 2 decimal places, 3.14. The answer for this worked example, 33,493.3 centimeters cubed. However, if you use 7 decimal places for pi, you get a different value, 33,510.3 centimeters cubed, pi to 7 decimal places. So the important lesson here is to always show your working. always quote how many decimal places of pi you have used. Thanks for listening. As always, any comments, queries, or constructive criticism in the comments section. Thanks again for listening.